Okay, this is Mr. Long, and today we're going to talk about solving mass problems. This is the third video that I have done under stoichiometry, and let's get this a little bit closer, and you can see I've already started. Now, the problem will be, or states, how many grams of carbon dioxide are formed when 42 grams of propane completely combusts in oxygen? That's our question. So we have our complete and balanced equation right here. Propane, C3H8, reacts with 5O2 to produce 3 moles of CO2 plus 4 moles of water. So our mole ratio or molar ratio is 1, let's put a 1 here, to 5 to 3 to 4. 1, 5, 3, 4. That's our mole ratio, our coefficient ratio. Now, I first asked you to memorize that part of the roadmap, which is what I call the central road. We have mass A that goes to moles A, and we can use the periodic table to convert to moles A. Then we go to moles B, where we use the coefficient ratio in the balanced equation to go to moles B, and then go to mass of B. So we've already done mole mass problems, or mass mole problems, and also moles A, moles B problems. So this is the third type of problem here. Now I've already started, and so we're going to start with what we're given. So we were given in this problem 42 grams of propane, which is C3H8. So go ahead and pause me for a second so you can catch up. So we start with 42 grams of C3H8. Now in the first step, you've got to have the same unit at the bottom that you have in the first that you have when you begin the problem, so they can cancel out. And so we're going to have grams of propane equated to 1 mole of propane. The second step is going to be moles A to moles B. So we're going to have moles A, which is moles of propane from the balanced equation, converting to moles of CO2. So I'm going to put moles of CO2 here. Okay, now lastly, whatever unit this is has to be bottom of this step here, CO2. This will always be 1 mole of CO2 when we're going back to mass to the grams of CO2. Now, you're taking notes on this video, and I want to see notes exactly like this. And you're going to send them to me on Friday. And now this will be due a week from this Friday. So anyway, let's see what we're going to put here. So we've got to calculate our molar mass. So carbon is equal to 12 times 3 is equal to 36. And then we've got hydrogen, which is 1 AMU times how many times 8 is equal to 8. So it's going to be 44. So we put 44 right here. So 44 grams of propane, which is the molar mass of propane, is equal to 1 mole of it. Now moles A, moles B, we're going to look at the balanced equation. So by propane, the number is 1. So you can put a 1 right here that you get from the balanced equation. By carbon dioxide, you've got a 3 here, so you put a 3 right there. And let me just bring this up a little bit. Okay, so we get these numbers from right here and right here from the balanced equation, moles A to moles B, the coefficient ratio. Okay, and in the last part, going from moles B to mass B, so 1 mole of carbon dioxide, which is what we are in right now, convert that to grams of CO2. So we got to do this. Carbon is equal to 12 times 1 is equal to 12. Oxygen is equal to 16 times 2 is equal to 32. It makes 44, actually. So we'll put the 44 right there. Now, we've got our steps filled in. And we can go ahead and cancel our units. This unit cancels with that unit. And the moles of propane cancel with moles of propane. Moles of CO2 cancel with moles of CO2. So I want us to pull all the numbers over. Okay, so I want you to show this step. So we got 42. The ones drop out, so no need to have that. Times 3 times 44 divided by 44. And the ones drop out. Now there's a couple of different ways you can do this. You can multiply these out, pull that number over, bring that number over, which is usually the best thing to do. But in this particular case, because these numbers happen to be the same, we can cancel them out. So now we've got 42 times 3. And you know that 3 times 4 is 12, that's 120. 3 times 2 is 6. So this is 126. And we're left over with grams of CO2. Okay, so we get this many grams of carbon dioxide that are formed when 42 grams of propane completely combust in oxygen. Let's go ahead and put a nice rectangle around our answer there. And there we go. So this was a pretty simple problem. Well, it looks hard, but it's not hard. Okay, just breathe deeply and take it one step at a time. Now, let's do another problem. How many grams of H2 can be formed by the decomposition of H2O? So we're going to start with water. So we have H2O right here, okay, in our balanced equation, and it's going to break down to H2 plus O2. Now we have to go ahead and balance this. So you can see that there are 2 oxygens on the right, and so you know you have to put a 2 there. So 2 times 1 is going to be 2, so now they're the same. But 2 times 2 is 4 for hydrogen. And you put a 2 here, 2 times 2 is 4 for that, and I have a 1 there. So this is a simple equation, which is why I didn't show the elements down here at the bottom. So it's a 2 to 2 to 1 ratio. And let's go ahead and put our grams of water right here. Let's say by the decomposition of 96 grams of water. So we're going to start with 96 grams of H2O, and you're going to have grams of water on the bottom equal to 1 mole H2O, and then you go moles to moles, so moles of H2O to moles of hydrogen gas. Then lastly, you're going to have moles of H2 to 2 grams of H2. Now we've got to fill this in, and because this is such a simple problem, we can do the math in our head. And hopefully you've memorized what the mass of hydrogen and oxygen is, and carbon. So 2 hydrogens is going to be 2. Oxygen is 16, that's 18. So you can put 18 grams there. That's equal to 1 mole of water. And here we look at our balanced equation. Well, we got 2 parts of water going to create 2 parts of hydrogen. Well, that's nice. They're both going to cancel out. And then in moles B to mass B, we got 1 mole of hydrogen, and we got 2 grams of H2 there. So we can go ahead and cancel out our units, and we can cancel out these 2's right there. And now we do want to pull our numbers over. So let me flip the page here. Or I guess we can probably keep it on the same page. So we got 96 times 2 divided by 18. Okay, and for this one I am going to pull out that calculator on the old phone here. And we'll do 96 times 2 is equal to 192, and it's going to be divided by 18. So divided by 18 is equal to 10.666, 0.666, etc. Now, because we've been rounding to the whole number, we'll just go ahead and you can either put 10.7 grams, or because we've just been rounding to the whole number, you can just say 11 grams of H2. So what we did here, this was a mass-mass problem. How many grams of hydrogen can 96 grams be formed by the decomposition of water? So be formed by the decomposition of 96 grams of water, excuse me. So we have water here that decomposes to hydrogen and oxygen. So we have a 2 to 2 to 1 ratio. So we start with what we're given, which is the 96 grams of water. And we do the first step, mass here, mass down here, mass to moles. So it's 18 grams of water to 1 mole. Normally we show how you get this, but this was so simple we don't have to. And use our mole ratio here, moles of water to moles of H2, the balanced equation. Now moles B to mass B. Okay, and so we get, these numbers can cancel, pull the numbers over, the ones drop out. 96 times 2 divided by 18, we pulled out the calculator, 10.7 or 11 grams of hydrogen. So that's this mass problem there. I'm going to give you a couple to do, and so let me pause this. Okay.